Okay, this is my Physics Lab 3 lab report. Um, the purpose of this lab is to describe the relationships between orbiting objects in space. This is done by using Newton's second law and calculating the forces of gravity that objects in the system act on each other. In the first part of the lab, I found the mass of a black hole using these physics principles. In the second part of the lab, I was able to create a figure-8 orbit of a ship around a moon and planet using the physics principles described. Okay, so the physics principles used in this lab are Newton's second law and the force of gravity equation. Newton's second law describes how an object's momentum changes due to different forces acting on an object. In this lab, the only forces acting are the gravitational forces of the objects. Part 1 of the lab is the main objective is to calculate the mass of the black hole. In this case, the system consisted of the black hole and this star. For my code, first part of code, define the mass of the star in delta T, which is in Earth day in seconds. Second part, this part calculated dp dt by calculating the change in momentum in relation to change in time. This next part of code calculated the net force in the parallel and perpendicular directions. And this last bit of code calculated the mass of the black hole by rearranging the force of gravity equation. The diagram was outputted by the program as well as the mass of the black hole calculated in 500 different iterations. I transferred this data into Excel and was able to calculate the mean mass, which ended up being 1.59 times 10 to 34 kilograms. Any discrepancy between the actual mass of the black hole and the predicted can be explained by slight differences each time the calculation loop ran. Okay, so part 2 of the lab was the main objective was to manipulate the initial velocity of the ship to create a figure-8 orbit around the planet and the moon. In this case, the system is the ship, the planet, and the moon. For my code for this, this first bit of code, the force of gravity equation was used to find the net force on the moon by the planet and the ship after finding the radii between the objects. And then for the second bit of code, the force of gravity equation was used to find the net force on the ship by the planet and the moon after finding the radii between these objects. For this next bit of code, I calculated the position and velocities of the moon and updated them each iteration using Newton's second law. And then finally, this part, through trial and error, I found that these values for the ship's initial velocity will allow the ship to obtain a figure-8 orbit around the moon for a period of time. This first output was of the moon and ship orbit. The ship maintained a figure-8 orbit for about 2.5 total orbits around the planet, and this other part was an output, and it says that the ship maintained orbit for 163.983 hours before crashing into the planet. So for this first what does it mean question, the rate of change of momentum describes the change in direction and speed of an object. The net force describes the change in direction from the perpendicular component of net force and the change in speed from the parallel component of net force. And for this second part, what if question, the answer I had was, in order to describe the entire system, you would need to describe each interaction between each object, the black hole, star, planet, and moon. The black hole would have the greatest impact on other objects, followed by the star, planet, and moon. In other words, the black hole would have the most dominant interactions in the system.